Hey everyone, this is Mr. Lambert with your lesson and notes for today, Wednesday, the 24th of February, 2021. Today we're going to be hopping into lesson 4 if we were in our textbooks. For chapter 8, again, we are dealing with functions. The whole point of this is we're going to be dealing with functions today, looking at different representations of functions. So how we can write these out as a linear function, how we can write these out as words, how we can write them out using a function table, and of course how we can graph the outputs of a function table and show that on a coordinate plane as a linear function, the straight line that goes through all of the ordered pairs that make up that function. The reason we're doing this is eventually what we're moving on towards is using those graphs and those function rules in order to be able to create what we call inequalities, to show if a function is less than, greater than, or equal to basically another function. So that's kind of what we're moving towards, which we'll be getting into as we move on into next week. But this week, especially here at the beginning of the week, we're really focusing on different representations of a function. So today we're going to start with a real-world link. So we'll start with the story problem here, work through this together, and then we'll do a couple of examples, which should get you ready for your guided practice today. So here's our problem today. It says a group of friends are going to the museum. Each friend must pay an admission price of $9. So here is what we are working with. We know that $9 is the price of admission, and we know that a group of friends are going to the museum. We don't know how many are in the group. So we want to figure out a function that could show how much it would cost for them to get into the museum if for any number of friends that go. So first thing would be we'll fill out this function table. So we have a table here that's going to show the cost of admission. That's going to be the outputs. That's what they're going to show. They're going to show the total cost of admissions. So we have the number of friends going in as X, and we have the number out going as 9. So I know I have one friend. I know the output for that. If my input is X, my output is 9. Okay, so 1 and 9, and it's 2 here. So we need to know, first of all, a function. So if I were to write this out, I'm actually going to work a little backwards here. I'm going to find the equation that shows the cost of N tickets, because that's going to be my function rule that I need to work through this graph. So if each one of the X, for every X, I know it's going to be $9, right? But I know for my next one, it's going to be another $9 plus this $9, so it would be $18. For this one, I know it's going to be 3, so another $9 on top of this, so it would be $27, and then another $9 on top of the 27, it would be $36. So as I look at my function table here, even though I'm adding $9 every time, to get the function to work, I'm not just adding 9 to X. If I added 9 to 2, that would be 11 as my total, and that's not correct. I need it to be $18 because there's an additional $9 every time. So actually what I'm doing is repeated addition, which is multiplication. So what am I multiplying by? Well, this is 9 times 1. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So 9 times my X value is going to equal my Y value. Or sometimes you'll even see the fancy guys on YouTube say the function of X is 9X. The function of X is just another fancy way to say your Y value. So in this case, here's what we've got. Now we need to complete the table of ordered pairs. So let's see. We have 1 and 9. So remember, the X value is going to be our left and right value. Our Y value will be our value up and down on the Y axis. So my X is 1. I'm going to go over 1 and then up 9. So just below the 10 here, that will be my first point. There's my first point here. 2 and 18. So I'll go over 2. That's my X value. My Y value is 18. So just under 20. Between 15 and 20, there we go. 3 and 27, so over 3 up 27. All right there. And 4 and 36, so over 4 up 36, just above 35. There we go. All right, and I should be able to then take a line and draw it straight through here. There we go. There is my linear function. Now, I call this a linear function because if I were to describe this graph, ladies and gentlemen, it's just a straight line. That's actually what we're doing here. These will all be linear functions. We're going to get a straight line. And in this case, our straight line is moving almost directly up through the middle quarter of our quadrant. So again, if I were to describe the graph, it is a straight line, which means I know it is a linear function. And because we already worked ahead a little bit, we know that the cost of the tickets as an equation would be this here. It would be 9x equals y. Or we could say, if we were to say this out in words, we know that each ticket, or the cost of the total amount of tickets, will be 9 times the number of people that are in the group. Then list the ordered pairs for the cost when 5 friends go to the described location. So in this case, I'm going to have my same thing. I'll have 9 times my x value, which would be 5, so 9 times 5 will equal my y value, and 9 times 5 is 45. And I know that my price here is in dollars. So I know that my x value, so my ordered pair here, my x value that I put in is 5, and my output, what I got out of that would be 45. 545 would be my ordered pair. There we go. So remember, there are 4 different ways that we talked about this already. We have, of course, you have the problem in words. You have the thing that you need. So just like as we looked at the problem, we knew that what we were looking for was something that is 9 times the number of friends that we have. We wrote that out as an equation. So 9x equals y. We filled that in using a function table. So once we figured out that function rule, we could create a function table, and then we have all of our inputs, all of our outputs, and then we actually showed that visually as a graph as well. So there's 4 or 5 ways already that we've talked about how we can represent a linear function. All right, we're going to move on. All right, here. So again, I'm not going to read this top part, but we are working on dealing with both numbers and words as we're working with linear functions. So let's look at these next 2 examples, and then we're going to go on and get you ready for some independent practice today. So number 1, it says the drama club is holding a bake sale. They are charging $5 for each pie they sell. So write an equation that finds the total amount earned, which would be T, for selling P pies. So the number of pies that we're going to sell, that would be P, and then T would be the total number, or the total amount earned from selling the pies. So in words, I would say that the total earned equals 5 times the number of pies sold, or $5 times the number of pies sold. So my answer for T will be in dollars. And then for my variable, I would let T represent the total earned and P represent the number of pies sold. So to write that out as an equation, here we have T equals 5 times P. There's our equation. Now, if we were to go ahead and put this into a function table, it would look something like this. We would have our table, but instead of x and y, in this case, you would have P as your input, and your output would be T. This would basically be your x value, and this would be your y value. Your input is always your x, your output is always your y, or function of x. That's how that will be shown. And then we would just plug numbers in and find the total amount using our function, basically just like we have always done with in and out boxes. All right, so that's how we would do that. So there again, you've got words from the story, you've got an equation being shown, and then you can put those values into a function table using your rule, and then we could graph those ordered pairs coming out. Number 2, it says, in the science report, Mia finds that the average adult breathes 14 times each minute when not active. write an equation that finds the total breaths B a non-active person takes in m minutes. So if I let B represent the total number of breaths and m represent the total number of minutes, the total number of breaths equals 14 times the number of minutes because they breathe 14 times each minute. So B equals 14m. Again, in this case, if we were to write this out using a function table, the m value would basically be our x. It's our input. The b value would equal our output, or what comes out of the function table. All right, I'm going to skip these little bottom ones because I want to move on to one more. These two because I want us to see how these look when we're graphing them out, because you're going to need to do some graphing today. So number 3, it says the student council is holding a car wash to raise money. They are charging $7 for every car that they wash. So we would if we were to write an equation to make a function table to show the relationship between the number of cars washed C and the total amount earned T, here's what it would look like. So again, this is our input, or our x value. This is our output over here. This would basically be our y value if we were to plot these out. So we've got an in and we've got an out. And then it says 7C here is our total, because the total amount earned would be $7 times each car that they wash. So 7C. And again, we could just plug these numbers in. So the input would be 1 for one car. 1 times 7 would give us $7 as an output. For 2 cars, well, there's $7 for each car that gets paid in. That would be $14. So again, we're multiplying our input by 7 to get our output. Or if we were to write this equation then, or this table out, 7C, of course, would be our rule or our equation. 7C equals T. But if we were to write this out using words, we could say, using the assigned variables, the total earned T equals 7 times the number of cars washed C. So the equation is T equals 7C. So there we go. You can write these as sentences. You can write these as equations, which is your function rule. You can write them out showing all of your values using a function table. And then, of course, right here would be a graph of what we just saw in this table right here. So we can actually go through, and each one of these would be an ordered pair. So our first ordered pair here would be 1, which would be our x value, and 7. There we go. Now, you see 0, 0 here, and that would be at our origin, because if we didn't wash any cars, we got no money. So our total value would start at the origin. So 0, 0, then we go to 1, 7, 2, 14, 3, 21, just like here on the chart, and 4, 28. And then if we wanted to, of course, we can draw that beautiful line, because, again, this is a linear function. All right, so there we go. There's looking at taking a real-world situation, showing that situation as an equation, which we have done in the past, or an expression. These are going to be equations, of course, because we're going to have a number that something's going to be equal, and these will have 2 variables. Remember, you need an x, or an input, and a y, or an output variable for your equation to show a function. So we can show those as an equation. We can show those in words like we did in the last 2 problems. We can just write out basically that equation using words. We can show it using a function table, which will take our rule and then show all of the inputs and outputs. And then, of course, we can graph those on a coordinate plane to show our function as well visually. That's what you're going to be doing today for your guided practice and your independent practice. If you have questions as you're working through, please make sure to give me a call, and we can work on a couple of these together today. You will have less questions overall to do, because you're actually going to be breaking these down into each of those different ways of representing your function. All right, good luck. If you have questions, please let me know.